Hey guys, I'm really excited to share a super fun AI model that I trained to predict the outcome of NBA games based on the players who are going to be playing in the game. And we'll just start right off with some examples of what it can do. Here we have a chart showing what the model thinks would happen if the full strength Boston Celtics played the full strength Denver Nuggets at home. So the Celtics are at home. In this example, it thinks the Celtics would win 77% of the time and they would outscore them by 20 points or more 14% of the time. Now, personally, as a Celtics fan, I'm terrified of the Nuggets, and I'm not completely sure that I agree with that one. So I decided to run it a few more times with a few different permutations of where is the game being played, who are the players that are playing, these kinds of things. And you can start to imagine the possibilities of, I want, LeBron James and Steph Curry on the same team. You can do that with this NBA model. So let's just scroll down and keep this example going. All I've done now is I've flipped who is at home. So if I put Denver at home instead of Boston, the model thinks that Denver would win 55% of the time. Now, an interesting conversation that I am not going to get flamed for in the comments is who's a better player, Nikola Jokic or Jason Tatum? Yes, I know Jokic is actually a better player, but does the AI model think so? We can actually find out. Let's keep the game in Denver and take Jason Tatum out of the game. If we do that, then the model thinks that the Denver Nuggets will win 66% of the time. So their win probability has gone up 11%. Pretty hefty amount. However, if you put Tatum back in the game, keep the game in Denver, and take Jokic out, the Denver Nuggets probability of winning drops down to 42%. So that's a drop of 13%. So it thinks Tatum is worth 11% and it thinks Jokic is worth 13%. It shows that it thinks they're comparable, but Jokic is better. Again, you can quibble with that. I think I roughly agree with that prognosis. Just a quick note, in my original take, I realized I forgot to tell you where to find everything. If you go to huggingface.co/thinkingrock/NBA, you can download everything that I'm about to show you for free. So the model architecture code, the weights, the example notebook that allows you to trigger all of the outputs, all of that is available here. You can check it out with Git, and you can see the individual files in the Files tab. Let's actually take a look at the code that runs this model, and then I'll show you how to use the attached example Python notebook to create your own player combinations. So this is the PyTorch code that's actually creating the model, and it's pretty standard transformer architecture, to be honest. The same thing that's underneath ChatGPT, Gemini, Stable Diffusion, all of these things are using transformers. In fact, they're so flexible that even things like Tesla's self-driving feature, is using transformers. You need something called self-attention. You need a MLP module. You put those things in a block. And then really the only interesting that's happening is you need to have a few different embedding layers. And embeddings are what I think is the special sauce of this model, where it takes each player and attempts to break it down into about 1,000 different attributes. And those attributes do not correspond to something like scoring or passing or something like that. It is simply how a player interacts with other players, both on their own team and against the opponents. So, for example, if one particular player just seems to have your team's number, then that would be represented in the embeddings, but it would not represent the fact that they score 30 points a game on average. And that tends to make a model that rewards winning more so than any sort of counting stat. And that's exactly what I was going for. So something that I found was the 2023-24 Celtics, they actually tend to slightly overperform my expectations. So for example, it says they're about as good as the 2018 Warriors. And I think most people would probably say, 2023, 2024 Celtics, probably not as good as the 2017, 2018 Warriors. But if you look at their winning and their actual results of the games, they actually look pretty similar from a results standpoint. So that's what the model rewards, is essentially results. How much did you beat other teams by? It is not a simple, net score counting stat. It definitely takes into account who the players are and how they interact with each other. So let's get into how we actually get these players to interact with each other. Here is the example IPy notebook, and it is available in the repository that I showed you before, huggingface.co/thinkingrock/NBA, files, and you can just check out this whole repository and run this yourself. It is this example.ipy notebook. So the first cell you can just run without any changes. It's just setting up the model and doing some imports. And then in that same repository, let's just maximize this for space, there is 2 files that you need to reference to be able to get the players and, importantly, the age of the players that you want. So, for example, this list is sorted by the amount of games that the player has played. The model does not have completely perfect data, so Michael Jordan is not in here, unfortunately. Basically, every game since 2000 is in here. But let's just say we wanted to replace someone on Denver with, say, LeBron James in his prime. So we'll just take LeBron James, we'll replace him with the person at the end of the Denver Nuggets bench, and then we'll put him in his prime, which is not age 12, but you have to reference age 27. Yeah, that sounds about right, is 12. So what you have to do is you have to find the player that you want in player tokens, take that token, and replace them in here. And then you have to find the age that you want them at and take that token. And this is a process, if you don't know, called tokenization that is very important in machine learning. So let's do that. And yeah, now the model thinks that Denver is going to win 70% of the time if you put LeBron James on the Denver Nuggets. That sounds pretty reasonable to me. Let's even play around with it a little bit more. What if you took someone like, I don't know, Kevin Garnett, and you put him on the Celtics? Would that bring it back to pretty even? So let's just replace the last player on the Celtics bench with Kevin Garnett in his prime. And it brought the win probability back in Boston's favor a little bit, but actually not that much. So the model thinks really highly of LeBron James, which makes sense. LeBron James is an awesome basketball player. So yeah, that is the model and code. It's available at Hugging Face. There are instructions in the README of how to install the right version of Python and install the dependencies. There's also a little bit of usage, but if you've gotten this far in the video, you've pretty much heard everything that you need to know. And just a little bit on how I got the data to do the training. It was this repository. Shout out to Swar for making the NBA API Python package. Okay, guys, that's it. I have actually an iOS application that should allow you to have a much easier interface to play around with this soon. And I think it'll be a really fun way to, create a starting 5 with your friends and see who can actually create the better one. It would be really fun to know who would be better, Steph Curry and LeBron versus Kobe and Shaq, that kind of thing. Okay, guys, take care.